Welcome to my YouTube channel, a Brainery of Civil. Hello students, welcome to my YouTube channel, a Brainery of Civil. Today I am going to solve the second assignment of fluid mechanics. Shall we start? First question. So you can see here in the first question, if a Mohr circle is drawn for a fluid element inside a fluid body at rest, it would be, that is, for example, I have taken one fluid element. Obviously, whenever an element is in the fluid, it will be subjected to compressive forces in all the sides. So this is one compressive force, this is another compressive, this is this one, that is sigma here, that is same. And now if we draw a Mohr circle, so the center of Mohr circle will become sigma plus sigma by 2 comma 0, that is sigma comma 0. So if I draw a Mohr circle, this is center, and radius will become sigma 1, radius is equal to sigma 1 minus sigma 2 by 2, that is sigma minus sigma by 2 is equal to 0. So you can observe a point Mohr circle on the normal axis. As radius is 0 and the center of Mohr circle is laid at a distance sigma from origin, this is origin 0 comma 0, this is a point Mohr circle. On which axis? This is on normal axis, this is shear axis. So on normal stress axis. Clear? So the answer is C for 1. And so burden gauge measures. So it is an instrument other than YouTube manometer, piezometers. So these are all some mechanical gauges which are useful for measurement of pressure in different forms. So coming to burden gauge measures. So this burden gauge measures local atmospheric pressure. Okay, with the help of burden gauge, you can able to measure local atmospheric pressure. Wherever you are, the atmospheric pressure at that location can be measured. So the answer for 2 is C. Okay, and next question. When a liquid is in contact with solid, if the forces of adhesion between the molecules of the liquid and the solid are greater than cohesive forces among the liquid molecules, the phenomenon occurs. Very most important concept is lied in this question. First of all, we need to know what is the difference between adhesion and cohesion. So I am writing here, cohesion is attraction forces between same type of molecules, and adhesion is attraction force between different types of molecules. For example, if you take water and glass in case 1 and mercury and glass in case 2. So there are different molecules in the water. The attraction between these different molecules is nothing but it is a cohesive force. And the attractive force between water and glass, this attractive force, it is nothing but it is adhesion, adhesive force. Okay, so if this adhesive force is more than cohesive force, that is, if I pour some water in the tube, it will rise. Y means this is angle of contact. So here theta is less than 90 degrees. So if it is water, because attraction between water and glass is more than attraction between molecules of water. Okay, that is here adhesion is greater than cohesion. Okay, so if adhesion is greater than cohesion, the liquid will rise in the tube. Okay, he mentioned that adhesion is greater than cohesion. Okay, adhesion is greater than cohesion. So obviously capillary will rise. For example, if we have considered, if I pour some mercury, okay, so this will fall, and here the angle of contact theta is greater than 90 degrees. Okay, so here cohesive forces are greater than adhesive forces. So in this case, the liquid will fall. Clear? Next question. A floating body with center of gravity G, center of buoyancy is B, and metacentric height is M, is stable when? I'll give you one important trick here. MGBS, Mahatma Gandhi bus station. You remember this? Okay. So for a floating body, metacenter is above G and B. So if it is okay, then the floating body is stable. So in this case, BM is this much and BG is this much. BM is greater than BG. Clear? So the answer is A for fourth question. And select the correct statement. So you can observe here, I am drawing one graph. So this is absolute zero pressure. And somewhere here it is atmospheric pressure. And here I want to measure, it is PA1. The pressure which is above atmospheric pressure, it is nothing but it is gauge. And the pressure which is below is nothing but it is vacuum. Okay, so this is, I am taking it is PA2. So from this, PA1 is equal to atmospheric pressure plus gauge pressure. So this PA1 is absolute pressure at this level. Absolute pressure at this level. So from this equation, absolute pressure is equal to atmospheric pressure plus gauge pressure. You can also write gauge pressure is equal to absolute pressure minus atmospheric pressure. Okay, this statement. And from this, PA2 is equal to atmospheric pressure minus vacuum pressure. Okay, so this is the concept, and the only option matching is B. So the answer for fifth question is B. And now, question number 6. The standard atmospheric pressure is 101.32 kPa and local atmospheric pressure is 91.52 and pressure recorded was 22.58 kPa gauge pressure it is equivalent to. So he asked atmospheric pressure. So somewhere for entire India, we will take only one value as a standard atmospheric pressure. This value is not available at all the locations. There are different atmospheric, local atmospheric pressures at different areas. So now we need to calculate the absolute pressure at our location. Absolute pressure at our location is equal to local atmospheric pressure at our location, that is 91.52 plus how much pressure which is more than atmospheric pressure, that is gauge pressure 22.48. So you will get it is 114 absolute. Okay, so the answer is C for question number 6. And next question. For inclined plane submerged in a liquid, the center of fluid pressure on one side of the plane will be. Generally, for example, it is a surface and there is one plane here. So this is one inclined plane. Okay, so making an angle of contact theta. So generally this will have centroid somewhere here, h bar. Okay, and from the center of pressure h bar Cp is equal to h bar plus Igxx sin square theta by h bar into A. So obviously h bar Cp is lied somewhere below h bar, right? Okay, so that is center of fluid pressure is h bar Cp and this h bar is centroid. So h bar Cp is lied below the center of gravity. So the answer is 7. C is the answer. Okay, and next question. If a small concrete cube is submerged deep in still water in such a way that the pressure exerted on all faces of the cube is P, the maximum shear stress will be. For example, I have taken one cube element. The pressure is acting same on all the directions. So P, this pressure P is nothing but it is a major and minor principal stress. So maximum shear stress tau max is equal to sigma 1 minus sigma 2 by 2. So if it is sigma 1, this will become sigma 2 automatically. That is P minus P by 2 is equal to 0. So answer will be 0 for 8 question. Okay. And coming to 9th question, the depth of center of pressure for a rectangular lamina of height h and width b. So that is, there is a rectangular lamina. So if I see, and this is coincides with the water surface, this height is h. If I see from sides, it will be b into h. With the longest edge vertical, that is longest head height is vertical, and the top of the edge touching the water surface. This top is touching the water surface. Center of pressure is equal to h bar Cp is equal to h bar plus Igxx sine square theta. Here theta is 90 degrees. Okay, and h bar into A. So h bar is equal to obviously h by 2 plus Igg. Obviously it will be bh cube by 12 about centroid, and sine square 90, and h bar is equal to h by 2 into area A is equal to b into h. If you will calculate, you will get it is 2h by 3. Okay, so the answer will be C. Very simple problem. But this is the most important equation to calculate center of pressure. And next, last question for this assignment. For liquids, will capillarity height increases or decreases with rise in temperature? As temperature increases, surface tension decreases. So to calculate capillary rise, H is equal to 4 sigma cos theta by rho g d. That is, H is directly proportional to sigma. So whenever as temperature increases, alpha value, that is, this is not alpha, this is sigma. Sigma decreases. What is this sigma? It is surface tension. So that is, as temperature increases, surface tension decreases. As surface tension decreases, capillary rise also decreases because it is directly proportional to surface tension. So capillary rise also decreases. Okay, so the answer will be B for 10th question. And I am not explaining remaining 3 problems in this assignment because there he asked 2 questions, but he provided only 1 box. So the way of asking is different. Okay, this is end of the assignment. You can solve. Thank you.